The Costa Concordia, the biggest salvage ever. On September the 16th, 2013, 100,000 tons of steel, water and debris were pulled upright in an operation called parbuckling. It was the make or break moment in the career of senior salvage master Nick Sloane. The day when any one of thousands of unknown factors could have spelled failure and the end of a brilliant career.
Okay, we're going up 10%.
By dawn the next day, the ship lay upright, ready to be refloated and towed away. Costa Concordia capsized on the night of the 13th of January 2012, tragically killing 32 passengers. One man, South African salvage master Nick Sloane, led the massive engineering project to turn her upright again and lift her off the rocks.
We had 33,000 tons of steel, 20,000 tons of cement, over 15,000 individual dives.
For the first time ever, the story of the senior salvage master's coordination of this unique operation can be told, from the day he set foot on the beautiful Mediterranean island of Giglio.
I came from New Zealand straight to Italy, and we went over the plan in Ravenna. But when you actually come and see it, and on the the island of Giglio, and you look at the island and you look at the rock, and then the ship, I think it's a lot more difficult than the photograph. And then when you actually stand on board, you get the sense of actually how big it is.
800 men and women worked under Nick Sloane's direct command, and thousands of others labored in shipyards across Italy to design and build the structures needed to make the parbuckling work. On the night of the 13th of January 2012, Concordia's captain, Francesco Schettino, ordered an unauthorized close sail-by of the Tuscan island of Giglio, a maneuver designed to entertain islanders and passengers alike. The ship struck a rock that ripped open her hull. She lost power completely and began drifting dangerously out to the open sea, but mercifully, the wind pushed her back to the shore. Although 4,000 passengers were rescued, 32 people drowned in the chaos that ensued. The day after the disaster, Captain Schettino was arrested as the dramatic search for survivors continued. All but 2 of the bodies were recovered. Miraculously, a couple of Korean honeymooners were rescued 2 days later. They had survived on biscuits and bottled water as the ship sank. Very soon, islanders realized that the cruise liner wreck itself demanded immediate attention. Concordia was full of food, chemicals, and heavy oil. A leak would have been an ecological disaster and ruined the island's tourist economy.
There was the threat of a potential environmental disaster. If the ship had been ripped open, the fuel would have leaked out of the tanks, and this would have polluted the whole coast, including the coast of Tuscany.
The Dutch company Smit Salvage won the bid to carry out the oil removal, called debunkering.
It was Friday night, the 13th of January, when it happened. And we immediately mobilized a team. We had here 4 trucks loaded, and they went down to Italy. And when I arrived on the scene in my position as operations manager to to assist in the first stage of the operation. Then the equipment came on board a crane barge from our partner Neri, arriving on scene.
Working with local partner Neri Salvage, the delicate process of removing all the ship's fuel began, as islanders watched anxiously.
The danger was that of the ship collapsing or moving with our divers working inside the hull. And this would have been fatal for them.
2 months later, the job was done. The local population gathered on the quayside to show their appreciation as the debunkering crew sailed away. The 350-meter-long ship rested on 2 rocky ridges that led to a 70-meter underwater cliff. Concordia not only threatened to sink, but also to break in two as she bent between the rocky outcrops. All the weight of the steel and furnishing of the cruise ship was concentrated on the weakest part of the structure. The ship represented a mortal threat to the livelihood of the islanders. The sea around Giglio is a nature reserve. A unique species of giant clam lives at the bottom of the reef Concordia rested on. Engineer Giovanni Ceccarelli is a naval architect, and he came up with an idea that he was convinced would save the island. He put his plan to local firm Micoperi, and they made a bid for the salvage.
The idea was always to protect the environment, and in order to do this we always believed that the ship had to be removed whole.
In April 2012, Costa Cruises awarded a $450 million salvage contract to the Italian firm Micoperi and US giant Titan Salvage to remove the wreck. Giovanni Ceccarelli's plan seemed simple enough, but would prove to be a massive engineering challenge and require the most advanced computer analysis and design. The consortium called in senior salvage master Nick Sloane to manage the project.
Every job, you have a portion of luck that you need, and you take your luck when you can get it. So it's important that you plan and prepare, but you need that bit of luck.
Sloane, the fearless South African master of ship salvage, is famed for dangerous work all over the world. An unassuming mariner, he is known for his dry sense of humor and ability to thrive under pressure. He was called to the Concordia site from another nautical disaster on the other side of the world.
When you're going onto a burning ship, you've got no idea what the cargo is. These big container ships carrying thousands of different types of products, and sometimes they react with heat or water, so you've got no idea what the manifest is. So there's always a sense of risk. I think it suits the people that have a bit of adrenaline junkie factor behind them.
Despite his easygoing manner, Nick Sloane has no less than 30 years' experience in ship salvage.
It all started, I think, when I was on SAF Marine, and there was a burning ship off the Cape called the Castello de Belver, and there was a Spanish VLCC supertanker that eventually broke in half. The bow section had to be towed out 200 miles, and then explosives was put around the bow to release the buoyancy, and then she was let go into the bottom of the ocean. And after that, I decided that that was more my line of career.
Costa Concordia is the longest project he has worked on, but before that, another was even more stressful.
The Tasman Spirit in Pakistan, that was quite a challenge. The ship broke up in the harbour entrance. There was a lot of oil, a lot of political pressure to get it out. So that was sort of 7 months of stress plus time. We had to finish before the monsoon.
Over the years, he's learned that no vessel is too big or difficult to raise from the seas, not even the largest cruise ship wreck of all time.
You get used to planning and seeing ships in this condition, so what other people think is quite dangerous, you've already mitigated those risks before, so you know how to make it safe for people to climb all over a ship that's at an angle like this in the background.
The Titan Micoperi plan involved securing the ship and building an artificial reef to rest her on before righting her in an operation called parbuckling. Although other ships have been parbuckled, such as the battleship Oklahoma after the Pearl Harbor attack, nothing quite this complex has ever been attempted before.
The first phase is the stabilization of the ship, using cables that hold this element, which is lying on its side, resting on its side, and we need to prevent it from doing this.
In April 2012, the first jack-up barges arrived to prospect the subsea surface in preparation for securing the ship with chains attached to anchor blocks installed on the rocks. Carlo Femiani is Micoperi's head salvage master, who explains the first difficulties the team encountered.
Unfortunately, the undersea surface proved to be harder than we anticipated. We had to engineer special chisels, and with these chisels, make holes in the granite, and then use perforating drills to penetrate the rock so as to be able to drill down.
During the summer of 2012, Nick Sloane became increasingly concerned that the island's hard granite might slow the pace of drilling and push back completion of the anchor blocks.
This is a drilling operation here, and it's very shallow. You can see the rocks, so we have to work around the rocks, and they're landscaping the granite. So behind it you'll see the landscaping operation. They cut into the granite to position the anchors. Then the drilling machine comes into the anchors and drills piles 16 meters into the granite.
At last, by October 2012, enough anchor blocks were in place to guarantee the ship would not sink. It was a crucial milestone.
The 16 strand jacks already on the port side. That's just to hold the stabilization wires, so that gives us 1,000 tons per anchor, which is 4,000 tons to hold her in position.
Drilling holes for the platform pylons proved equally difficult.
We had to landscape the rock, put down templates so as to exactly level out the perforating pylons that we will need to position.
As winter approached, the ship was now secured, and the salvage was well underway. The Costa Concordia lay on her side, held back from slipping into the dark, watery abyss by massive chains. Now, the long process of parbuckling could begin. It was one of the most complex salvage operations in maritime history, and would take years.
The ship weighs 45,000 tons, and with the water and with all the structures we're about to build on it, it will reach 60,000 tons. So we have to rotate 60,000 tons from 65 degrees incline to the vertical.
We've had 3 different engineering teams plus ourselves making our own assumptions, and we've come to a range of what the weight is. So we're planning for the worst case scenario and hope for the best.
Passenger ships are characterized by having the superstructures, in other words the upper decks, built with light material so as to keep the center of gravity low, and they have the stronger structures in the lower decks. So the difficulty will be transferring the forces from outside into the ship so as to rotate her.
The idea in itself was very simple. Given the undersea slope, the reef would have to be extended, using a cement bed and steel platforms on which the ship would rest once righted. The Italian company Micoperi specializes in building oil platforms and was confident. although building so many platforms in a row had never been attempted before. Huge ballast tanks, called sponsons, would need to be attached to the ship's side in order for it to be floated. Before it was rotated, they would be attached to the port side only, so their weight and gravity would help pull the ship upright, yet at the same time stop it from rolling over when righted. They would then be attached to the starboard side. Their buoyancy would have to lift Concordia off the rocks.
When we refloat her, we're putting the life jacket around her, or armbands, and we're going to recreate external buoyancy. We're not going to worry about achieving internal buoyancy due to the damage.
The key element in this ship's salvage would be the strand jacks. These are hydraulic pulleys that use small movements to move huge masses. The high number of cables and the small movements multiply the forces the hydraulic pulleys are able to exert.
In total, we'll have 124 strand jacks used on the operation itself, which is, again, quite a few multipliers more than ever used before in salvage.
For the first 6 months, nearly all the work was underwater, and this required the presence on site of over 100 divers. They were lodged in this enormous floating hostel, the Pioneer, where they would eat, rest and sleep between their grueling shifts of work. The Pioneer barge was also where the cement was produced that was pumped into the massive underwater nylon bags, a process called grouting.
We've got hyperbaric doctors on the team. We've got paramedics, 14 medics in total. So we're ready for trauma, we're ready for diving accidents. We'll have 10 chambers, but decompression chambers on location. So we're pretty well set up for protecting the diving operation.
Although the divers worked on the anchor blocks and the subsea platforms, they were mainly employed building an enormous cement mattress, an extension of the reef the wreck was caught on.
All the activities, especially the underwater activities, are carried out with no dispersion of material, so it's all done with sealed and closed circuits.
The FEM analysis, that's a model that they've made of the ship. It had 904,000 structural components. It's the biggest model ever made anywhere for finite elements analysis.
We have a team of divers who compile a report every day, comparing it with the state of the ship the previous day.
The ship's hull was inspected daily to check for new cracks and fissures. Salvagemasters worried that the constant deterioration of the ship could put the operation at risk.
We have a program that just calculates structural parameters, and every day imports this data, processes it, and it's very nice because the pictures are colored, and we say that as long as there is no red or blue, we are happy.
Biggest risk as we come into winter, we've got to make sure that we protect her as much as possible. So there's a lot of pressure on just to get the hold-back anchors in, which will be finished this week, and then well, I guess that's the biggest risk is the winter weather.
In December 2012, as winter storms began pounding the rusting hull of the Costa Concordia, Nick Sloane was presented with a worrying new factor. His engineers said that there was a risk the bow might break off during parbuckling. The team brainstormed and found the only solution was to give the weak bow of the ship extra buoyancy. They designed special blister tanks that fitted the curved hull like gloves, and these were added to the already massive engineering contracts given to shipyards around Italy. On the 13th of January 2013, the families of victims of the Costa Concordia disaster gathered to commemorate that tragic night, together with the islanders. It was the first time in 12 months that the salvage operation stopped for a whole day. By February 2013, The anchor towers on the inshore side of the ship had been completed, and the 22 strand jacks that would pull the ship upright had been installed.
There's 11 towers, each one has 2 of the blue pulling machines. They're hydraulic rams. They grab the wire and they put a stroke of about 450 millimeters, and then it goes back to recover the next stroke. So they're going under the water around the anchor bollards, and then they go all the way underneath the Concordia herself. So this gives us about 11,000 tons of pulling capacity.
Meanwhile, Italian shipyards Rossetti, Cimolai and Fincantieri were building the massive undersea platforms and buoyancy tanks in preparation for the parbuckling. Consortium engineers checked that the units were built to millimetric precision. With all the weight of the cruise liner concentrated on the side of the hull and between the rocks she was resting on, it was inevitable that the ship would begin to bend. It became vital that the design and construction of the sponsons perfectly matched their housings on the hull.
Well, we'd like to have more space and bigger tolerances, but unfortunately to get that much buoyancy on the midship section, when we designed it we thought 50 millimeters of tolerance would be enough. That's actually reduced to 38 millimeters, and the worrying thing was that if you had a bad winter and there was any distortion or deflection in the ship's hull, that the actual sponsons would start touching each other with the deflection.
The hard granite undersea surface had required templates to be fitted so as to accurately align the platform pylons. There was no room for error.
We had to make a template that they used for setting the platform legs. We used the same template to put on the seabed for drilling the holes into the seabed. So the margin for error for the angle for the holes to be out was less than 1% of error, otherwise the legs would not fit.
In early 2013, at last the massive steel structures that the salvage team had designed would begin to arrive, and the project entered its critical phase. A year after the tragic wreck of the Costa Concordia, maritime history's biggest salvage operation was in full swing. The first platforms began arriving from shipyards around Italy. One by one, the 6 enormous platforms were lowered. The last, the smallest, went underwater in June. The platforms were welded to the barge to keep them stable during transit, and on the day, once positioned over the undersea template, they had to be detached. The massive shear leg of the Micoperi 30 held the platform in place as it was freed from its support, and slowly the barge was removed. The platforms could be lowered while underwater cameras on ROVs monitored progress. Salvagemasters worried that a single error could jeopardize the whole operation. But the months of careful engineering paid off, as the platforms sank underwater into the precisely located holes drilled to host the pylons.
The 3 platforms on the midship section are just about the size of a football field, and you've got a footprint of over 40 meters between some of the legs.
Over the same period, the massive ballast tanks arrived too, and were hooked onto the side of the ship. The tallest was the equivalent in height to an 11-story apartment block. Again, with millimetric precision, the caisson was slowly positioned over the hull of the ship. It was then slid into the housings on the side of the ship.
The big sponsons are like an 11-story building, just a big steel box, 10.5 meters by 11.5 meter footprint, and then 22 meters high for the short ones and 33 meter high for the tall ones. And they get cladded onto the outside. So on the port side, we'll have 11 for the parbuckle, plus the blister tanks. And what they do is that when she rolls over, as gravity starts to pull her over, they enter the water and create buoyancy and slow her down.
Now that the sponsons were fitted, came the critical moment of mounting the bow blister tanks.
Blister tanks are pretty big. They're 36 meters wide, 21 meters high, and 30 meters long. And basically they're shaped like the flare of a bow. So the bow has a very fine flare, and then this is like a cervical collar. So basically it supports the ship around the neck as you roll it.
The massive steel structures were built to fit snugly against the Concordia's bow. But actually placing them on the ship was the most complicated of all the engineering tasks of the whole salvage. The blisters had to be sunk and then gently slipped under the ship's nose. It was a delicate and time-consuming task, but was a necessary step to ensure that the ship would not rip open on the day she was parbuckled. By the end of August 2013, 18 months after the tragic wreck of the Costa Concordia, the parbuckling operation had reached a crucial turning point. Every item of the massive salvage was designed to the most minute tolerances. Even the smallest unpredicted force could cause breakages of hinges and cables that could prove fatal to the operation. The ship's condition was a source of constant concern.
The lever for the breakout force is about 450,000 ton-meters of leverage that we have, and that's quite phenomenal. And it's also a crushing force, so it wants to crush the ship because you're actually pulling the ship together as you rotate it. But the ship, we put in doubler plates on the turn of the bilge, 40 millimeter plates, 5.5 meters long, to try and spread that load all the way around the turn of the bilge and into the keel.
Once the caissons and blister tanks had been mounted, the cables that would turn the ship were attached. They would eventually be connected to the undersea platforms. The massive chains that held the ship back and would help turn her upright threatened to cut into the hull itself on the day of parbuckling. Divers laid specially designed cement bags with grooves so the undersea chains could slide through them.
Basically, when the chains come underneath the ship, we have little hawse pipes where we fabricated to allow the chain to come through. And then next to the chains we have what we call the Kit Kat bags, and that's to support the keel of the ship as she rotates over onto the keel. The chains go into the gaps between the Kit Kats and displace the sand that we put in there, and then the hull is supported on the Kit Kat bags themselves, and that stops the chain from being forced up into the ship and cutting her.
A row of red strand jacks were mounted on the top of the sponsons to provide massive pulling power.
On the top of the sponsons you can see the red strand jacks. There's 36 of them on the outboard side, and they go to the outside of the platforms, and that gives us just on 13,000 tons of pulling capacity from the top of the sponson. So that's like a big lever that just rotates as you pull together, and you've got about 24,000 tons of actual pulling force, but several 100,000 meter tons of momentum.
Once the ship had rotated 25 degrees, the sponsons would begin working in favor of the salvers.
Basically, strand jacks do the first 25 degrees of rotation, and then gravity takes over, and then you introduce the buoyancy into the sponsons as they get immersed, and you control the ballasting of that just to make sure everything's in balance. So you want it to be a smooth and steady movement from where she is at the moment all the way up and then onto the platform. And the smoother you can make that, the better the chance of success.
Nick Sloane was now ready for the big day. The islanders were ready too. The equipment to do the job had been engineered and constructed. He was optimistic it would work, although there were still many surprises in store.
We were pre-tension up to about 40% of the expected forces the night before. We'll start just after daylight. So it'll be about 5 hours to get through the critical phase, and then about 3 to 5 hours for coming down and resting on the platform. So 8 to 10 hours, we hope to be finished by sunset.
As the big day approached, Nick Sloane took stock of the massive organization that he led for a year and a half. He was not the only salvage master on the job.
We had four complete separate operations going on, and this is the one team's doing the towers, the whole back systems. Then you got the Pioneer, they're doing the grouts. Then you got the team on the Concordia itself doing all the preparations, the welders. And then the offshore project was the large diameter drilling for the platforms to come in. So they're four completely separate teams and projects. And then you have a Salvagemaster running each one of them. So I was just the one that had to take the fall.
You need a strong leadership and to be able to basically bring all the fine and talent that's on board to get them all going in the right direction. A lot of different nationalities, but some really good talent for those nationalities.
Yeah, over 500 at one time, just before the parbuckle. But if you look at the rotation, people with their back-to-backs in rotation, so maybe 700 to 800 people have been on site. And that's a big team.
On the morning of September the 16th, 2013, all was ready for the cruise liner to be righted. Over 600 TV and press journalists gathered on the quayside to broadcast the event in real time worldwide. It was the salvage of the century. It was the culminating point of Nick Sloane's successful career. The day before parbuckling, storm clouds raised fears that the operation might not go ahead.
Yeah, my wife came over, so she came over for 4 days, and she said, listen, don't waste my time. Yeah, it's a long way to come over, so it's 2 days each way. And we had that storm the night before, with all the electricity and the heavy rain, and we thought maybe we should postpone it for a few days, just to double check everything. But when you're all ready, if you start postponing it, then you'll never do it. So you've got to say, listen, we're ready, let's do it.
In the end, the parbuckling was given the green light, after just a few hours' delay.
It's simply that last night the weather wasn't very favorable and we had a few operations that overlapped. But everything is absolutely within the norm. It is as it should be according to a certain sequence of preparation that is absolutely as planned.
As the storm subsided, the command post was pulled in front of the ship. Nick Sloane took his place in his headquarters, located in front of the bow of the giant wreck. He had announced that it would take about 9 hours. The rest of the day would be the adventure of his life.
Yeah, just confirm all personnel of the Concordia.
The strand jacks were set in motion, and as they pulled the cables that were wrapped around the hull of the ship, just 4 centimeters at a time, they began applying 24,000 tons of force. For hours, nothing seemed to happen. "45,000 tons of steel began rotating under the pulling force of the strand jacks. The blue and red hydraulic pulleys only had to apply sufficient force to move the ship a few degrees so that its mass was closer to the center line, where the weight of the sponsons and the ship's steel itself would come into play. During the afternoon, a few centimeters of the sunken part of the swimming pools began to emerge. The ship was indeed moving. Constantly monitored by underwater ROVs, the ship continued to move, centimeter by centimeter. Then, 8 hours into the parbuckling process, all activity was stopped. The cables that were slowly being pulled through the strand jacks had become tangled, and a crew was sent aboard to get them straightened out. Extra floating barriers were also laid to control any leaked pollutants. The process was much slower than anyone had imagined. As the sun set over Giglio Island, the media waited and speculated on the outcome of a salvage now into its second year. The critical phase of the Costa Concordia salvage began on the morning of September 16, 2013. It was the culmination of 19 months' work, led by senior salvage master Nick Sloane.
But if you have a rock like this that sticks up like a knuckle, then you have to tear it off. And we don't know the exact forces required for that because we didn't know the profile of the rocks. So then when you started the breakout, when we got to 4,000 tons, 5,000 tons, 6,000 tons, 6,000 tons was getting to the higher side of what we expected. So 6,500 and 6,800. People were very quiet thinking, like, hold on, you know, we're right up at the top side of the curve already. But at 6,800 she started coming.
The ship had rotated the first 25 degrees and was now turning under its own weight.
At 25 degrees, we knew that we had her. It was just a matter of just slowly putting her down. So what happened was you're pulling from 1/3 of the ship. So you got 1/3 on the bow, 1/3 on the stern that's not been pulled, and that's where you expect it to sag like a banana. But it came up nice and straight, very parallel. We had sensors all the way along. And the maximum deflection we had for the whole operation was 1/4 of a degree.
The sponsons hit the water and slowed the rotation until, under Nick Sloane's precise orders, the valves were opened and they began to fill slowly with water, providing the soft landing he had anticipated.
It's just the first phase of basically the refloats, the important part to get her away from Giglio. But if we couldn't parbuckle, then there's no refloat. Then it became a cut job. So we didn't want to think of that.
By 4 in the morning, the ship was upright, resting on the massive cement and steel structure. Nick Sloane was surprised by the welcome he received back on dry land.
Came into port, by that time it was just after 5, but we didn't expect anyone to still be awake. But there was a lot of people awake. It took a bit longer, but the results were better than we hoped. So that was really nice to see that at 4 o'clock in the morning. Thanks very much, Sebastian. So we had a couple of beers, went to bed, and then the next day we had a pig roast, barbecue. That's when we sort of really relaxed.
The next day, the damage to the starboard part of the ship could be examined. The 45,000 tons of the cruise liner had weighed down on the 2 areas that were in contact with the rocks, crushing the balconies and outer cabins. But the steel structure was essentially intact.
At that period, the search and rescue guys, we had to do a survey to see how dangerous it was, steel hanging down before they could get in the water. So it took about 10 days to clean up all the dangers for them. They got in the water and they finished last Friday with the search and rescue side of it. One body's confirmed to be identified. We're hoping that the second one is as well, because obviously it'll be a lot better for everyone if we could get some closure on that.
After parbuckling, the first task of the salvage team was to make the ship accessible and as safe as possible.
Well, what we've done is on board we steam cleaned it to get rid of all the muck and taking out all the stuff in the passageways so that we can go through and do a full inspection. At the moment they're spraying the fumigating it because there's some airborne particles which aren't very good for you.
In the meanwhile, the next steps of the salvage operation were being planned. Nick Sloane took a deserved break.
You know, you're on a bit of an adrenaline high for weeks before it happens, and maybe nerves as well. So when you get home, your body collapses, so you just want to relax, sleep. We went up onto the river on the South African-Namibian border. It's no cell phone, no internet, and just canoed and did some rafting, rapids, camping on the side of the river and barbecuing.
Keeping in touch with family while on a salvage far away is one of the greatest challenges of the job.
Well, there's a wonderful thing called Skype. And so, but if you talk to your family at least 10 minutes a day, which I've learned to do, I think it keeps you in touch with them.
In these unique images from the air, the full structure of the wreck can be seen, resting on the cement bags and undersea platforms. Now the sponsons were nearly all underwater. The ship sat snugly on the custom-built steel cradle. Nick Sloane knew this salvage would go down in history.
Biggest grout job in history, the biggest diving project in history, most ROV footage, 33,000 tons of steel. You can build the world's biggest supertanker with that. So if you add all of those together, it's just a crazy project.
It had been a dangerous job, and the salvage workers had risked their lives over the months.
A lot of cuts and bruises, 1 or 2 crushed fingers, compound fractures, broken bones. We've had about 20 serious injuries, and then 1 very serious with a fractured skull. But that was treated correctly. I mean, they're all back. So when he fractured his skull, he fell, bounced off a piece of steel, broke his shoulder, arm, and then landed on the deck, shattered his climbing helmet and fractured his skull.
Nick Sloane himself knows from personal experience how important it is to have paramedics on standby.
So there's been some times where I've been hurt without anyone there, and the treatment that you get could be really bad, life-changing. So you want to make sure whoever comes on board goes home in one piece, or at least if they're not in one piece, they will be back to work within 6 months.
Work began immediately to prepare the starboard side of the ship to hold the sponsons that would float the wreck away.
The worst thing now is the weather, winter, to see what other damage is going to happen. But hopefully we've done a whole lot of winterization planning. We're putting large steel girders on the offshore side that will keep it rigid onto the platforms. And then from the bow all the way inshore to the island itself, next week we'll put a tubular brace, and that will hold the bow so she won't be able to move in a yaw, and she won't be able to roll. So she should be fine for winter then.
The lights of the cruise ship were turned back on, recalling the scene on the tragic night when she sank nearly 2 years before, taking the lives of 32 people. The November storms were on their way. The Concordia would have to wait another winter before being taken to her final resting place.